So, good afternoon, everyone. Assignment discussion as per the date of 25. In a closed flask of 5 liters, 1 gram of H2 gas is heated from 300 to 600 kelvins. Which statement is not correct? So, listen, students. Closed flask means a constant volume. A constant volume, what would be the relation we read? A constant volume given quantity of, for a given quantity of gas, pressure is having directly proportional relation with temperature. So that to solve this problem, I am going to utilize the relation like as T1 by T1 is equal to T2 by T2. Listen, students. First, P1 we don't know, P2 we don't know. So I am migrating P1 and P2 towards one side. P1 by P2 is equal to T1 by T2. Yes, students. Now come to my point, students. P1 by P2 is equal to temperature given regarding pressure. P1 300, it's of 600. That means 300 plus 300 is means 100. Means what, students? In 5 liters flask of 1 gram hydrogen gas, if you heat the temperature from 300 to 600 kelvins, pressure what will happen? Double. Means first option, pressure of the gas increase, right? Second, rate of collisions increase. Yes, students, because with increasing temperature, kinetic energy of gaseous molecules increases, so the rate of collisions will be increases. Next, third option, number of moles of gas increases. No, students, how number of moles of gas increase? Because just is heating gas of same quantity, means 1 gram of hydrogen gas. So quantity of hydrogen gas is not, quantity of hydrogen gas won't alter, so that number of moles won't alter. Next, students, the energy of gaseous molecules will be increases. Yes, students, with rising temperature, kinetic energy of gaseous molecules will be increases. So third statement is wrong statement, students. Next, question number 2, students. So listen, question number 2. SI units of gas constant are. SI units means in joules, students. In joules, R value is 8.314 joule Kelvin inverse mole inverse, students. Next, question number 3, students. Question number 3. 4.6 grams of gas at STP occupies volume of 2.24 liters. The gas can be, students. Listen, students. 4.6 grams gas occupied volume is equal to 2.24 liters at STP, students. As students, it is given, but he is asking which gas is that. For that purpose, first we have to detect that gas molecular weight. Okay, students. So if we want to discuss that gas, detect that gas molecular weight, we have to recall one more basic statement. That's nothing but at STP 1 mole of gas can occupies 22.4 liters, students. Students, 2.24 liters contain mass is nothing but 4.6, then 46 grams of gas occupied volume is equal to 22.4 liters at STP. Students, that means what? At STP 22.4 liters contain weight is nothing but 1 mole weight. 1 mole weight means molecular weight of gas. So our gas should possess molecular weight 46, students. If you consider NO2, students, N14, oxygen 16, Two options, 32 plus 14 is nothing but 46 students. So our answer should be NO2 students. And next students, question number 4. So listen, if the absolute temperature of ideal gas becomes double, the pressure becomes half, the volume should be, he is asking students. So to solve this problem, we have to utilize the relation like P1 V1 by T1 is equal to P2 V2 by T2 students. So listen, P1 V1 by T1 is equal to P2 V2 by T2. So first, at absolute temperature, ideal gas, if the absolute temperature of ideal gas is doubled, means I am going to make T2 as to T1 students. And next students, what is saying? Pressure becomes half. P2 becomes as P1 by 2 students into P1 by 2. And next students, volume of gas would be, means P2 he is asking students. So remind, he said first initial condition P1 V1 by T1. T1 gets cancelled students, P1 gets cancelled. Then 2 into 2, 4. So V2 by 4 is equal to V1 students. So V2 is equal to 4 V1 students. Means volume increased by 4 times students. Next question number 5 students. Density of a gas is found to be 5.46 grams per dm cube at 27 degrees and at bar pressure. What will be its density at STP? What will be its density at STP? So now, come to my point students. Here he said, listen students. Question number 5. Density formula students first. Density is equal to P into M by R into T. Yes students. Density of a gas found to be 5.46 gram per dm cube at 27 degrees C and at bar pressure. Next, what will be its density at STP student? At STP its density is asking. Gas in both cases same, so molecular mass same. First, D1 is equal to, first gas D1 is equal to P into M by R into T1. Okay students. Second, from this you can calculate M is equal to D into R into T1 by T1. Next student, second gas D2, means in second case he is asking what will be its density at STP. Density is equal to, at STP density I am considering D2, P2 into M by R into T2 students. Yes students. Now come to my point students. In both the cases gas remains as same, so M is equal to D2 into R into T2 by P2 students. Both gas remains as same, so D1 first gas I am considering D1 into R into T1 by T1 is equal to D2 into R into T2 by T2 students. Yes students. Now R gets cancelled. That means D1 into T1 by P1 is equal to D2 into T2 by P2 students. Now come to my point students. In first case, if you consider density of a gas found to be 5.46. So 5.46 into, listen student, T1 means what students? Here he said T1 as 300 Kelvin students. By, at first case he is saying pressure as pressure as 1 bar, 1 atmosphere students. D2, we don't know students. So STP D2 we don't know. Temperature STP 273 Kelvin students by, listen students, P2 also 1 bar. So what will happen students if you consider this 273 bars and it's of 0.02 students, then what will happen students? So 2 into 10 power minus 2 into 300 student, 10 power minus 2 into 3 into 100 student, so 3 into 2 that equal to 6 students. Now so continue. Okay. Question number 6 students. 380 ml of gas at 27 degrees, 800 mm of He weight, 0.455 grams. Then molecular weight of gas is students. Listen students, volume given and at the same time pressure given, at the same time temperature given and weight is given. He is asking us to calculate molecular weight students. So first PV is equal to nRT students, weight by gram molecular weight into R into T students. Next students, volume is given in ml. So convert volume ml into liters. Volume 380 by liters means 1000 into pressure students 800 by 760 students. So P into V. Weight is given as 0.455. And next, gram molecular weight unknown student. R value 0.0821 into temperature students, that is 300 kelvins. That means X is equal to 0.4555. So 0.455 into 0.0821 into 300. Listen students, into 1000 into 760 by 380 into 800 students. Now, if you did entire calculation, you can obtain X value as 28 students. That's it. Next. Question number 7 students. Question number 7. 34.05 ml of phosphorus vapors, weight of 0.0625 grams at 546 degrees and 0.1 bar pressure. What is the molar mass of phosphorus? Same students, molecular weight he is asking. So listen, question number 7. Formula which we have utilized, PV is equal to M into R into T. So pressure into volume is equal to weight by gram molecular weight into R into T students. Now we have to detect gram molecular weight. Gram molecular weight is equal to weight into R into T by P into V students. Weight into R into T by P into V students. Next students, in terms of this question, that weight is given like this students. Listen student, here weight is given like as 0.0625. So 0.0625. Next, R value students, R value 0.0821 into temperature value students, that is 546 plus 273 students. So 546 plus 273. That means how much student? 9 and 7 4 11. So here 819 by P into V. P into V students means pressure into volume student. Here pressure is given as 0.1 bar, 0.1 atmosphere. Volume is given as 34.05 ml. 34.05 ml. ml have to convert it into liters. So by 1000 students, if you did entire calculation, you can obtain 1247 students. 1247 rows. Next students, question number 8. So next question number 8. Calculate the total pressure exerted by mixture of 8 grams of dioxygen and 4 grams of dihydrogen confined in a vessel of volume 1 dm cube at 27 degrees. Listen student, he is asking pressure of mixture. Pressure. So you know that PV is equal to nRT, P is equal to N into RT by V. But listen student, here pressure of mixer is equal to, listen student, N mixer means he is mixing 8 grams of dioxygen and 4 grams of dihydrogen. Means N of H2 plus N of O2 into R into T by V students. And now come to my point students. As for this, if you consider N of H2, N means weight by gram molecular weight, 4 by 2 students. So 4 by 2. Next, number of moles of O2, 8 by 32 students into R value 0.0821 into temperature student. Temperature is 27 degrees. So 300 kelvins by students. Volume is given as 1 dm cube. 1 dm cube is nothing but 1 liter students. So pressure of mixer is equal to, if you did entire calculation, you can obtain the pressure of mixer like as 56 approximately students. 56. Next, question number 9 students. 2.9 grams of gas at 95 degrees occupies same volume as that of 0.184 grams of dihydrogen gas at 17 degrees. At the same pressure, what will be the molar mass of gas? What will be the molar mass of gas? Listen students, here he is asking molar mass of gas by giving certain data. And listen students, here 2.9 grams of gas at 95 degrees occupies same volume. Here 0.184 grams of dihydrogen at 17 degrees. At the same pressure, what is the molar mass of gas? Listen student, volume of two gases remains as same. So volume formula what student? PV is equal to nRT, V is equal to nRT by P. For two gases, volume remains as same students. So as per that data, V1 is equal to V2 student. That means N1 into RT1 by P1. N1 into RT1 by P1 is equal to N2 into RT2 by P2 students. Pressure remains as same students. He said the same pressure he maintained gets cancelled. RR gets cancelled. N1 into T1 is equal to N2 into T2 student. N1 weight by gram molecular weight. Listen student, in terms of first substance 2.9 grams of gas. So 2.9 by gram molecular weight unknown. 2.9 grams of gas at 95 degrees student. 95 degrees means 273 plus 95. 8 and 16 means 368. So 368 kelvins. That equal to students N2. N2 means our second hydrogen gas 0.184 by 2 because N2 means number of moles of hydrogen into T2 students, that is 17 degrees, 273 plus 17. How much students? 290 students. Now we need what student? X. So that your X is equal to. So listen student, if you shift X towards that side, it will becomes as 2 into 2.9. 2 into 2.9 into 368. 2 into 2.9 into 368 by 0.184 into 290 is equal to X students. If you solve that, you can obtain the X value like as 40 students. Next students, question number 10. A dry cleaner, Drynex contains small bits of aluminum which reacts with caustic soda, to produce dihydrogen gas. Volume of dihydrogen gas at 20 degrees and 1 bar pressure will be released when 0.15 grams of aluminum reacts. Now, come to my point student. He said in Drynex, aluminum is going to mix with NaOH, then hydrogen is released, that released hydrogen occupied volume. So listen students, actually aluminum and NaOH reaction in aqueous medium is, listen students, 2Al plus 2NaOH plus 2H2O gives rise to 2NaAlO2 plus 3H2. Yes students. Now come to my point student. As per this equation, 2 moles of aluminum gives 3 moles hydrogen, means 2 into 27 grams of aluminum on reaction with NaOH gives 3 moles H2. Okay students. Now we have to detect how many moles of H2 is liberated when 0.15 grams of aluminum is reacted. Listen students, 0.15 grams aluminum released H2 is equal to, students listen, 2 into 27 grams releases 3 moles, then 0.15 releases 3 by 2 into 27 into 0.15 students. Then released moles is nothing but totally you can obtain the number of moles 3 into 0.5 like that. Here 3 ones, 3 nines. Yes, 3 threes and furtherly 3 0.05s. Yes or not student? So that you can obtain the moles like 0.05 by 6 because 3 into 2 number of moles obtained to you. If number of moles obtained to you, you have to calculate volume. You know that PV is equal to nRT, V is equal to N into R into T by P. Number of moles, you know students, 0.05 by 6 into R 0.0821 into temperature he gave like that 293 Kelvin students. Temperature he gave 293 kelvins. And furtherly students, listen, PV is equal to nRT, so V is equal to nRT over by P student. P is nothing but, here pressure is given as totally he gave the pressure like as 1 bar student. If you solve this entire one, you can obtain the value like 202.5 students. Next, question number 11. Calculate the temperature of 4 mole of gas occupying 5 dm cube at 3.32 bar. So question number 11, students. Calculate the temperature of 4 moles of gas occupying 5 dm cube at 3.32 bar. So students, PV is equal to N into R into T. He is asking us to calculate the temperature. Temperature is equal to P into V by N into R. P into V by N into R. So listen student, pressure is given 3.32 and next V is given as 5 dm cube. 5 dm cube means 5 liters by N is given as 4 moles. R is given as 0.0821 students. If you did entire calculation, you can obtain 50 Kelvin students. Next students, question number 12. A plot of volume V versus temperature for a gas at constant pressure. A straight line is passing through the horizon. Plots of different values of pressure are shown in below. Then he is asking the relation between pressure students. Students, you know that higher is the pressure, lower is the volume. So that P4 greater than P3 greater than P2 greater than P1 students.